Hello, my dear students, and the rest of the learners. Welcome to part 14 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to be looking at our last control structure in the series by the title or by the name for loop. That is, for loop control structure. My name is MemJM, or you can simply call me Emily Swap. When is for loop used, or what is for loop? For loop is a control structure that is used in situations whereby execution of statements is repeatedly done for a specified or predetermined number of times. The predetermined number of times are counted either upwards or downwards, with a counter variable being incremented or decremented respectively each time a loop is performed. This counter is set either to the start or end value. Therefore, the two formats or types of for loop are the incrementing for loop, that is one that counts from the lower limit to the upper limit, and the decrementing for loop, which is initialized to the upper limit but decremented to the lower limit. The syntax for the for loop structure is therefore as follows. We have for and then initialization statement, where we assign the first value in the counter. We initialize counter. And then from there, we check the condition. If the condition is true, we perform certain activities. That is, we execute the statements, statement 1, 2, 3, 4, up the last statement. And then once all the statements in the loop are executed, the last statement or the last action to be done is now to change the value of counter, that is increment counter or decrement counter, and that's what we are calling the counter change. So that's a syntax. Now, how is it implemented, or how does the compiler work with for loop? So the steps of execution for this for loop is as follows. Number one, you initialize the counter, either with the lowest bound or the upper bound element. Once you are done with initializing the counter, the next statement or the next activity is to test the condition. If the condition evaluates to false, we come out of the loop. That is, we proceed to the next step. Otherwise, if the condition evaluates to true, we go to what follows after the last step. I repeat. One, we initialize the counter. Then we test the condition. If the condition is true, if the condition is true, if the condition is true, we come out of the loop. Now, the condition, the way we set our condition is key. Because if the condition evaluates to false, if the condition evaluates to false, we proceed to the next step. The next step is we enter into the loop and start performing the activities there. Otherwise, once the condition evaluates to true, we exit. That is why the statement reads as follows. If it evaluates to false, proceed to the next step, that is step 4, which of course is entry into the loop, executing the statements. But if the condition evaluates to true, that will mark the end of coming out of the loop, or the end of the loop. And that simply means coming out of the loop. So if the condition evaluates to true, immediately, there will be no any other action to be taken. So if it evaluates to false, proceed to the next step 4. Else, go to what follows after the last step, that is exit the loop. So what is in step 4? In step 4, we are executing the statements in the loop. And then statement 5, or the next action to be done, which usually is like it is part of the statements within the for loop, is to ensure that before you check the condition, again, you have incremented or decremented the counter value, or what we are calling the counter change. Once we increment or decrement the counter based on the type of loop you're working with, we can go back to step 2. Step 2 is we retest the condition. If the condition is false, we move again to step number 4. We execute the statements. Otherwise, if the condition is true, we exit. Then step number 6. Step number 6 is if we don't go to step number 2 above, that means if we don't retest the condition, if we don't retest the condition, the compiler will not be able to determine whether to continue executing the statements or not. So we have to go back to step 2, which is test the condition. And if the condition evaluates to false, we continue. We enter in the loop again. But if the condition evaluates to true, we exit. That means there will be no repetition. So during execution, the counter is first initialized to a certain value, either to lowest value. If the for loop is incrementing, that is the lower bound value, or highest value, that is upper bound, if the condition or if the for loop is a decrementing for loop. Then the loop continuation condition is checked, such that if the condition evaluates to false, the statements within the for loop are executed, then the counter value is either incremented or decremented. Then the loop continuation condition is checked again, and the statements in the loop are executed again if the condition is still false, or the loop terminates if the condition evaluates to true. Let's see how we write the pseudocode for a for loop, a flowchart, and a source code for a program implementing incrementing for loop, compute areas and the perimeters of a circle whose radii range between the smallest to highest radius of your choice. The program then displays each radius, area, and the perimeter. Now the program then displays each area, or just as I've said, it displays each radius, area, and the perimeter. Always remember, when you are developing the pseudocode algorithm, you must have the title. So our title for pseudocode is pseudocode for computing areas and perimeters of circles with various radii. So we have the start. Next, we set the value of pi to 3.142. We then prompt the user for the smallest radius for his or her circles within the smallest radius. Then we prompt the user to enter the highest radius for his or her circles within the highest radius. And then from there, we check if smallest radius is greater than highest radius. If it is, we come out of the loop. Otherwise, we do the following. We compute the area using the formula pi times radius. We then compute perimeter using the formula 2 times pi times radius. We then display the radius, area, and the perimeter. And then we increment the smallest radius. And then we go back to step 7, where we check if the current value of smallest radius is greater than the highest radius. If it is true, we skip or we exit the loop. Otherwise, we repeat to compute the area, compute perimeter, to display the radius, area, and perimeter, and again increment smallest radius, and that will continue until when the value of smallest radius will not be greater than highest radius, and then we stop. So that's a pseudocode for our program. Let's look at our flowchart. As usual, just as we said in the previous presentation-based series, whenever you want to do a flowchart for a program, you must have its title. So this title is flowchart for computing area and perimeter of circles with the various radii. So that is our flowchart. As you can see, we begin with the start. Then we initialize the value of pi to 3.142. We prompt the user to enter initial radius and the last radius within the range, and then we read the initial radius and the end radius. Then we check or we initialize the value of initial radius to radius. In other words, we pick the value in the memory location called init radius and assign it in the memory location called radius. And then we check the condition. Is the value of radius, is the value in memory location called radius greater than the value in the memory location called end radius? If yes, we exit the loop. If not, we do the following. We compute the area by multiplying the content of memory location called pi times the content in memory location called radius times its content or the content in memory location called radius again. So we assign the value in memory location called pi multiplied by the one in memory location called radius multiplied by itself. We assign those results in the memory location called area. We do the same for perimeter. We pick the content in memory location called pi, multiply the content in memory location called radius, multiply the results by 2, and assign the results or the value gotten into a memory location called perimeter. We then display or we output the value of radius, area, and perimeter. In other words, we output the content in memory location called radius, we output the content of memory location called area, we output the content of the memory location called perimeter on the screen. Then we increment the value of radius. So we increment the value of radius with 1 and assign the results into a memory location called init radius. And then we again pick the content in memory location called init radius and assign it back to the memory location called radius. We check the condition again. If it is not true, if it is no, we follow the path for no. We perform those actions, and that will continue until when the value of radius will not be greater than the value in memory location called and radius. In other words, I repeat, when will this loop terminate? This loop will terminate when the value in the memory location called radius will not be greater. That means, I repeat, this part is very important for you, my dear students, and the rest of the learners to understand. When will this loop terminate? This loop will terminate when the value of the memory location called radius, the content in memory location called radius, will be greater than the content in the memory location called end radius. So once the value in memory location called radius becomes greater than the content in the memory location called end radius, that is when the loop will terminate. So with that, let's look at our program and see how this loop will work using a sample program. So the comment for a program is calculate areas and perimeters of circles. That's the comment. Whose radius is within specified range. And then we have our preprocessor directive. We have our main function there. And then the first statement is to request the processor to assign the value 3.142 in the memory location called pi, whose content is supposed to be 1 with decimal points, that is double, and the value there should not be changing. So we are declaring a memory location called pi, and we are telling the compiler that the content in this memory location should be of type double, and that value is not supposed to change. And once we have done that, we tell the compiler or the processor to assign 3.142 in that memory location that we have already declared, called pi. Then the next statement, we are initializing or we are declaring some 3 memory locations, which are end radius, init radius, and radius. You are telling the processor that the content in these 3 variables that you have declared is of type integer. We also declare 2 memory locations by the names perimeter and area, and we are telling the processor or the compiler that these 2 memory locations called area and perimeter will hold the value of type double or data that has decimal points. Data that has decimal points, but one which is bigger in size, that is type double. Then this statement will be displayed on the screen and the value for the smallest radius, and the cursor will blink on the next line. And then the user keys in a value. That value will be picked and stored in memory location called init radius, and this value is supposed to be of type integer, that is whole number. Then we prompt the user again to enter value for the highest radius. So this message will be displayed on the screen. Enter value for the highest radius, and the cursor will blink on the next line. The user will key in a value. That value will be rent, and it will be assigned or stored in the memory location called end radius, and the value entered is supposed to be of type integer. From there, we enter into the loop. And how will this loop work? This loop will work as follows. 1, we are telling the processor or the compiler to pick the content in memory location called initial radius, init radius, and assign that value into the memory location called radius. Once that is done, the next statement to be executed will be the compiler or the processor will check whether the value in memory location called end radius is less than or equals to the value in the memory location called radius. If that condition is checked, once that condition is checked and it is found that the content in the memory location called radius or called end radius is less than or equals to end radius, then the following will be done. 1, the processor will pick the content in memory location called radius, multiply by itself, then multiply the results with the content in memory location called pi, and the results gotten will be stored in the memory location called area. The next statement is compute perimeter. The processor will pick the content in memory location called radius, multiplied by the content in memory location called pi, and then the results gotten will be multiplied by 2, and they will be assigned in the memory location called perimeter. And then the statement that will be displayed on the screen will be perimeter of a circle whose radius is. The processor will pick the content in memory location called radius, and the content in the memory location called perimeter. So the statement will read as follows. Perimeter of a circle whose radius is perimeter. In other words, if, for example, the value in memory location called radius is 2.0, and the content in memory location called perimeter is 4.11, then the statement will read as follows. Perimeter of a circle whose radius is 2 is 4.11, and the cursor will blink on the next line. But something special that you need to remember, my dear students and the rest of the learners, is that in this statement, you can see that the content of the memory location called perimeter, when being displayed on the screen, will be formatted into a length of 6 characters, out of which 2 will be reserved for the fractional bit. And the next statement will be displayed is, and its area is, the processor will pick the content memory location called area and display this on the screen, but formatted in the following order: 5 characters, out of which 2 will be for the fractional part. Then once this place is any countant, the processor will move again from here and go to this part. So the content in memory location called radius will be incremented with 1, and the resource assigned back in the memory location called radius. From there, the processor will come here, check the content of radius, and find out whether the value in the memory location called end radius is less than or equals to the content of memory location called radius. If that is true, then the following activity will be done. Once this brace is encountered, then the control or the processor or the compiler will come back to this section of the program, the statement of incrementing the content of memory location called radius with 1. It will increment, and then once that is done, the processor will come back again here to check the condition to see if the value of the memory location called end radius is less than or equals to the content of memory location called radius. If that is true, this will be done. And then that will continue. Incrementing of radius will be done, and then the condition will be checked. So that will continue until when the content of memory location called end radius will not be less than or equals to the content in memory location called radius. So if the state is reached whereby the content of memory location called radius is no longer less than or equals to the content memory location called end radius, then the compiler will come out of this loop and skip or come out of the loop and perform the next set of instructions after the loop. And then, which is the next statement to be executed? It is tell the processor take back the control, the operating system, and end the program. So that's how the for loop works. My dear students and the rest of the learners, let's proceed and decode this program in Falcon IDE so that we can see how it will behave when executed. So as usual, we are going to launch our Falcon program in our computer. Then wait for it to load. Click on File, point on New, click on Project. Under New Project, click on Empty Project and click Next. Under project name, give it a name. So the name of our project is for loop. The compiler type is C. So we click on Finish. Then we right click on our project name, for loop, point on New, and then click on C File. The name which you are going to be given by default will be main.c. So we rename it based on what we want our program to do. So our program is for implementing for loop. So we are going to type again the name of our project or the name of our program as for loop. Then we click anywhere outside there. You can see the name is for loop.c. From there, we now type our program in the IDE here. So you type this set of statements or the source code just as I've explained. So in this editor section, you are expected to type this program that we have discussed line by line up to the end. So let's have our program in our IDE. So I'll just paste my program here. So this is our program. We have our comment here. We have our preprocessor directive there. We have our main function there. And then we have the body, as you can see. So remember to indent your program nicely let's ident our program so that it is readable. So this is the exact program that I've already explained to you, my dear students and the rest of the learners. So we just want to see how this program is going to behave, whether it will behave as we have discussed. So from there, you save your program. So let's save our program together with our project by clicking on Save All. And then we select the location for our project, as well as our file, and the file name, we give the name of our project. So you can retain the name which has been proposed or the name which you have already given to our project. And then you click on Save. So there we are. From there, let's compile our program by clicking on Run, then Compile. If our program has no errors, as you can see, you've been given the report that compilation is successful. Otherwise, if there are any errors, those errors will be highlighted or those bugs. And therefore, you are supposed to debug or remove those errors, and then you compile your program again, but you remember to save the changes. So because our compilation has been successful, we can click on Run, and then we click on Run menu. Once you click on Run menu, simply you are telling the processor to execute your program or perform the activities as outlined in your source code. So this is our screen for output. You can see it is prompting the message, or it is displaying the message. Enter value for the smallest radius. So I can enter my smallest radius as 5. Then enter value for the highest radius. Let me, for example, enter 10. So we want to have our program computing the perimeters and areas for all the circles ranging from the radius of 5 to the radius of 10. So once we press enter, you can see we are going to have perimeters of circles and areas being computed as follows. You can see the first statement reads perimeter of a circle whose radius is 5 is that 1.42 and its area is 78.55. Next, you can see it is the perimeter of a circle whose radius is 6 is this, and the area is that. And you can see it has continued all the way to the circle whose radius is 10. So the incrementing of the radius, you can see it has spanned from 5, 6, 7, 8, 9, 10. So once the value of radius has exceeded the end radius, that is when the program terminates. So, my dear students and the rest of the learners, that's how a for loop works. We can now proceed. So you click or you press enter key to go back to your program. You can now save or to save your program and then click on close all. Then you can exit from the IDE. And with that, my dear students and the rest of the learners, we have come to the end of part 14 of the series in which we are focused on the for loop. You can now proceed to part 15 of the series in which you are going to be looking at the introduction to some programs or what we call the functions. Congratulations, therefore, for learning part 14 of 29 on for loop control structure in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on the MLSWAP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading are subscribed. For any further correspondence, kindly write to us through the email mnswap@gmail.com. Thank you very much for listening to me. Let's meet in part 15 of the series, and God bless.